Cool. Alrighty, thanks everyone for coming. I've never given a talk to an audience listening via headphones before, so this will be interesting. I'm going to have to ask you to give visual feedback. So if you have a question, raise your hand or gesture really evocatively so that I know that I should stop and let you ask your question. Please feel free to interrupt me anytime. My name is Chris. I work at Tendermint Research. This is a co-presentation as we're talking about an interoperable protocol. It's an interoperable presentation with Dean from Agoric, and I will be talking about interblockchain communication. The polycentric interchain is already here. What do I mean by this? I mean that there exists an ecosystem of many different blockchains fulfilling many different purposes. More are being launched every day, and it's polycentric. Different blockchains are used for different applications. Different blockchains have specialized in providing different categories of assets or different kinds of utility to their users, providing hard currency, providing programmable contracts, providing more programmable and less safe or more safe and less programmable contracts, providing stable coins, providing decentralized finance, providing insurance contracts, etc. But at the moment, this interchain mostly is disconnected. Applications, decentralized applications, interact with one blockchain at once. Users have their assets and data locked up in different silos of different blockchains. We need a way to connect it, to allow this Cambrian explosion of blockchains and protocols to flourish and continue to develop independently, such that people can try out and experiment with different ideas, but still allow users to move their assets and data around as new blockchains, new protocols are developed with better rule sets and more advanced technology. So at Cosmos, we've been working on IBC, interblockchain communication, which is designed to be a general messaging protocol for this interchain, this set of blockchains. To do that, we've come up with a set of abstractions that we think capture what it means for blockchains to talk to one another, to authenticate data packets sent from other blockchains, such that applications, which you might think of as smart contracts or modules on one blockchain, can talk to applications, smart contracts, or modules on another blockchain, and vice versa. So just like you can think of as a rough analogy, TCP/IP is a messaging protocol to connect computers, which may be sitting in different data centers or in your pocket around the world, which have different physical hardware implementations produced by different companies, but they can all speak TCP/IP, the same protocol. IBC intends to serve the same role in the ecosystem of many blockchains. It's a protocol which different blockchains can implement, and modules on those blockchains can elect to speak and then use to talk to each other without any necessary case-by-case, pairing or bridges between these two blockchains, but rather this one general protocol. There are two layers, then, of this stack. And the first I've started to call, it hasn't yet picked up, but you can help me popularize it, the Tao of IBC, Transport, Authentication, and Ordering. The Tao of IBC covers what's necessary to transport data from one blockchain to another, because, of course, these blockchains reduce to actual computers running actual software in different places around the world, maybe in the future on your phone. And transport mechanism is necessary just to physically relay the data. Then the Tao of IBC handles authentication, what it means to say that data was sent by some blockchain and received by another blockchain, how blockchains can reason about parts, not the full, but parts of the state of other blockchains and use this to authenticate this data. And ordering. If you send packets between two blockchains, sometimes, not always, but sometimes, you want them to arrive in the order which you sent them, or in some order which is more constrained than any order, and the Tao of IBC handles that. So I mentioned earlier that we need a set of abstractions. We want these abstractions to capture the general set of architectures of different blockchains. So all blockchains have some kind of consensus algorithm, and we need a way to authenticate that consensus algorithm. We call that a client. And for IBC to be useful, that client has to be light. It has to be cheaper to verify that consensus algorithm than it is to just run the full blockchain. This is almost always true. Different blockchains have different light clients. In the case of Bitcoin or Ethereum 1.x, there's something called an SPV client, simple payment verification, that serves this role. In the case of BFT algorithms like Tendermint or Grandpa or Hot Stuff, You can summarize the consensus transcript so that you put certain signatures that the validators produce as a result of running the consensus protocol basically in a very long list, and then you can send compressed versions of that list to a light client, and that light client can use it to verify that the consensus protocol did in fact confirm some block, confirm some transaction or value. So that's a light client. It's the same kind of algorithm that you've thought about if you've ever worried about a light client running in a browser or a phone. But in the case of IBC, as opposed to running a light client on a phone, we're running a light client on another blockchain. So it's like writing an Ethereum smart contract that encodes the algorithm of a light client for verifying the consensus transcript of another blockchain. Then on top of light clients, which are the base verification layer, and the only layer, interestingly, with unique security properties, IBC always reduces to the security properties of the light clients. So unlike some other bridges that you might have seen, it isn't a protocol with security properties of its own. It just reduces to security properties of the constituent light client algorithms. On top of clients, we build connections, which are pairs of associated identifiers between chains. So unlike, say, sharding protocols, where the topology of the system is known, where there is some like numbered set of blockchains of shards in Ethereum or parachains in Polkadot, in IBC the topology is unknown. We only reason about local information. So all of the protocol is constructed as a system of interaction between two modules on two blockchains, which we usually call A and B, or Alice and Bob. And to establish a set of shared identifiers between these blockchains, we create a connection for which there's a handshake. So the two blockchains can be assured that they refer to each other by the same identifier, which is associated with a specific connection. Then, on top of connections, once you have a connection which exists between blockchains, you can create a channel which exists between modules. Modules are the general abstraction for independent units of executable code. So on Ethereum, a module will be a smart contract. On the Cosmos SDK, a module is called a module, unimaginatively. On Substrate, it's called a modular package. I'm not quite sure which. Most programmable or flexible blockchain frameworks have this concept, and it maps to what we call a module in IBC. Modules then can bind to ports, which are a little but not quite exactly like ports in TCP/IP, and once they've bound to ports, they can create channels with other modules. So if you have a connection, if I'm blockchain Alice and Dean is blockchain Bob, we first negotiate a connection. That has nothing to do with modules. It just happens on the blockchain to blockchain layer. And then some specific module, call it Aardvark, can utilize that connection to negotiate a channel with module Baloney. Sorry, first word I thought of, on blockchain Bob. So once Aardvark and Baloney negotiate this channel, they will be able to send and receive data packets to and from each other. Now, what those data packets consist of, IBC doesn't care about. It is a data agnostic or payload agnostic protocol, just like TCP/IP. So the Tao of IBC deals only with transport, authentication, and ordering. What the data means, that's up to the modules. This is really helpful because it means that when a blockchain implements IBC, when you build this transport, authentication, and ordering into your stack, you don't need to know what the actual packets are going to be. So someone could write a smart contract later that understands a particular packet. It could talk to a module on another chain, and you don't need to reason about that. You don't need to know about it before it happens because it's just up to the modules. Kind of talked about these. So a diagram of what this whole flow looks like. Once you've established a connection in a channel between chains Alice and Bob and modules Aardvark and Baloney, for sending a packet goes as follows. We start on module Aardvark. Module Aardvark decides that it wants to send a packet. It encodes some data in that packet. That data has some semantics. The protocol doesn't care, but let's say, for example, it's transferring tokens. So it encodes an amount and a denomination into the packet, sends that packet to the IBC module, which is a special module on chain Alice that understands how to route things around and understands the connections in the channels. The IBC module then confirms, writes that packet to the Merkle store. Blockchain A, number 3, finalizes the block, Then a relayer, which is responsible for the physical data transport, detects that that packet has been placed in the outgoing queue on blockchain Alice. The relayer constructs a transaction to blockchain Bob. Blockchain Bob then sends that transaction to the IBC module, number 8, on blockchain Bob. The IBC module decodes the metadata, doesn't decode the packet data itself, doesn't know what that means, but it decodes the metadata, figures out that the packet is destined for module Baloney, and sends it on to number 9, module Baloney, which can then handle it as it wishes. In the case of a packet containing tokens, it can mint.
I just wanted to insert one thing here on the bologna track, right? Which is, this is how the sausage gets made, right? It's very important that from the point of view of the programmer, in the same way that programmers can send packets over TCP without understanding the details of retry and timeouts and packet sizes and all that sort of thing, the client of this is not having to experience all this. They're just opening a channel, sending some data, done.
Yep, that's precisely correct. It would even be possible, albeit, I don't know, potentially dangerous, to implement a channel-like abstraction for programming between multiple chains which are connected over IBC. So if you ever used asynchronous send-receive channels in languages like Go, you'll be familiar with sending and then receiving on another channel, and or like a good example for this is also Erlang. That kind of abstraction can be implemented over this. So programmers don't need to worry about the underlying data transport and authentication architecture, except as it affects their security models. So unlike some sharding protocols, the security in IBC is not uniform. It depends on the security of these chains. So chain A could be the Cosmos Hub, it could be Ethereum, it could be like 3 validators in some guy's basement or on Amazon Web Services. It could even be one computer. That's all fine, but you as a programmer do need to be cognizant of that as you're using the protocol. The next layer on top, yes? Yeah, here.
So 4 and 6 is the idea that like blockchain A and blockchain B are part of that network, and like how does the relayer play there?
So the question was on numbers 4 and 6. These can be independent peer-to-peer networks. So these peers and these peers don't need to talk to each other, but there needs to exist at least one entity in the universe, which we call the relayer, and the relayer needs to pay attention to what's happening here and relay it to at least one peer in this blockchain. They are not responsible for authenticating any data. They don't need to sign anything. They're not a trusted party in any sense, but they need to perform the physical relay. Cool. The next layer on top is application layer packet semantics. So we want to standardize separately what it means for packets to be sent around, metadata authentication, what I just talked about, but also what each individual packet means, such that people writing contracts on different, or modules on different blockchains in the interchain can standardize on certain packet formats for certain tasks, like sending tokens, collateralizing stablecoins, making cross-contract calls, voting in governance systems, that sort of thing. So this we're calling the application layer packet semantics. We've just started on this. There are a few specifications in the proposal stage on our GitHub repo, which I have a link to later. But we hope that lots of people working on applications which make use of the interblockchain protocol will contribute to, it's an open specification process, and will specify the kinds of packets they're using, like Agoric has certain kinds of packets, which Dean can talk about in a second, and then other people who might want to also use those packets can use the same standard. So just like an analogy here is HTTP. HTTP is a packet standard on top of TCP/IP that says that this is what a packet contains. It has HTTP headers, and then it has body, and there are different methods, get, post, head, etc. Same kind of thing. Some examples of different packets are token transfer, for which you would encode a token amount and a denomination and maybe some metadata in an IBC packet, send it to another chain. Cross-chain account abstraction, where you would have an account on one chain delegate control to an account on another chain, such that if you had one like master multi-signature on Ethereum, you could use that to control other accounts which were connected to Ethereum over IBC. interchain code relocation, which is kind of like sharding, but a bit more modular, where you might decide that you want to summarize the code of a contract and some of its data in an IBC packet and relocate that contract to another blockchain, maybe as you're trying to rebalance load between shards. And then you can build full, higher-level programming systems on top of IBC, of which Agoric is a prime example.
Absolutely. So, right at the bottom layer, the other important thing about IBC is we talk primarily about chain-to-chain communication, but it also, the same protocol can enable chain-to-machine, single machine-to-machine, and so forth, to provide onboarding and offboarding or connections from applications or clients into the chain. And so out of here, you can see these layers of, the various different machines. On top of that is IBC, which provides that connectivity. And there are some apps that he talked about that one directly can build on IBC, like interchain collateralization, governance, the token transfer, and so forth. Agoric is a chain where it is agnostic to the consensus layer, though our current testnet and platform is built on Cosmos. And so we have a JS OCAPS layer that gives a different level of programming, a different level of abstraction, where it uses IBC as a data layer that can go between machines and chains. So one of the things it enables, just like with TCP, is you get a whole nother level of ability to build up a richer world on top of these chains, so we can have a single uniform computational platform that works across different instances of our chain, instances of instances of the Agoric chain, instances of Cosmos zones or platforms built on other consensus mechanisms. And then there's a set of apps that will enable. So for us, that will enable various oracles and smart contract platforms. And the question is, what will it enable for you when you build your own layer on top of this stuff?
Exactly. So all of the specifications are open source. We're currently going through an audit process on version 1 of the spec. I would encourage anyone interested to reach out, read, and contribute. You can find all the specifications and proposed standards. There has already been one standard proposal by the community for the interchain, as in by someone who wasn't employed by the company, for the interchain account delegation, and we hope there'll be many more. Eventually, the company should be a minority. It should end up being a sort of ecosystem standards group. GitHub.com/cosmos/ICS. Not IBC, it's a bit confusing. ICS, which stands for Interchain Standards. Thank you.
And as Billy said in the Cosmos, the general Cosmos thing, there is a hackathon at the end of the month as well at SFBW, a DeFi hackathon that will include Cosmos, will include Agoric Chain, and will include IBC as a thing that you can start to build with.
You could also start to build with it now, but I would only recommend it for, very adventurous coders. It's still green around the edges. Thank you.